Alright, well I've cleaned the retard gear train and the self timer or delay action, and I'm just going to put those in place now. So as you see, I cocked the shutter, which allows me to drop the retard gear train down into place. Retard gear train and the delay action have both been cleaned in an ultrasonic cleaner, which will loosen up and remove any corrosion products that were floating around on the surface. And I have since then lubricated them lightly with graphite powder, and I expect that they will run nice and smoothly. However, time will tell. Look at that stain there. And have a look at that. Just remove that. Yeah, that's fine. It's just a stain there where obviously the lever had sat and a drop of water probably sat on it and caused it to dry in one spot, and you end up with a rusty mark, not unlike a coffee ring. Let's get this delay action seated correctly in place. It's not dropping down for one reason or another. That looks better. Just checking the action of that. It definitely works. So I will tighten up those 3 screws. Put another couple of components in place, and we can check the action of the shutter and see how well it runs or not. Cocking ring, I want to rub some molybdenum paste around the inside edge and the outside edge. Need to hook that spring over its post, and the end of the spring is fairly open. It will hold there neatly when it's under tension. It's not enthusiastic to hold there when it's slack. Get this gear correctly coupled. That looks right. Check that the delay action tab is behind the ring there. That's all correct. Alright, a little bit of molybdenum paste on the surfaces of the speed cam. Let's drop this in place. Now I normally do my preliminary check with it set at the 1/8 position. That is running, of course, very, very fast. So it means I've got to swing in the retard gear train for greater, so it couples for a greater length of time with the main drive cab. I need to cock that shutter like that. Loosen the screw slightly. Move in the retard gear train end. Tighten the screw again. Put everything back where it was and test again. That's better. Slightly fast. So I'll remove the cocking ring again and move the retard gear train in slightly further for greater engagement with the main drive cab. You can also make slight adjustments to the speed by bending the pin on the top of the retard gear train arm inwards or outwards. But if the speeds were correct before you took the shutter apart, or in other words, if the speeds were correct when the last serviceman had finished servicing the shutter, as long as you don't bend anything and you put everything back in the right place, they will be correct again. That is definitely slow. So swing that retard gear train out slightly. This can be a lot of toing and froing in this process. It's not uncommon to get it right first or second time or third time, but sometimes you need to be doing quite a bit of toing and froing until you get your speeds in a satisfactory state. Always watching the mesh of the teeth on the gear here and the main drive ring. Now that sounds very promising to me. So at this stage I'm going to pop the front retainer ring on the shutter and go out to my shutter tester and confirm that that speed is correct, and come back and make any adjustments I need to. The specifications for shutters like this was that the shutter speed, the measured shutter speed, should be within 20% of the marked speed, and that repeatability between when you do multiple tests of the same speed, that they should all be within 10% of each other. For repeatability, that's more important, because if your speeds are all over the place when they're set to the same number, it means that you can't predict what sort of an exposure you will get, and it's usually a sign that there's a problem with the shutter. Either it hasn't been cleaned correctly, or if you haven't even cleaned it because it needs cleaning, or there is a problem somewhere else in the shutter. Well, I'll go away and test this and I'll come back, and when it's all ready I can close that shutter up. Well, those speeds are bang on the money, so that's good. So we'll remove the retainer ring. Lift the plate off. Fit this lever in place. Now this lever's job is to prevent you from being able to depress the shutter release if the shutter is not cocked. I didn't quite get that spring in the right side of the post. That's better. That component is occasionally left out of shutters, particularly if someone unfamiliar with the shutter has been servicing the shutter, because they don't know what it does and the shutter seems to work fine without it and they don't really know where it goes. So it gets left out. I'm going to check the self timer, the delay action, and check to make sure it sounds and runs smoothly. No, that sounds good to me. And put the shutter into the outer case. I've already cleaned these parts. Rub some molybdenum paste on the curved rack, the inner surface of that curved rack, and both the long edges. Doesn't need much, it's just to make sure that it's low friction against the case. Drop them into the case. This is easiest to fit if you first cock the shutter. Where are we? Somewhere about here. Oops, see, just dropped that out. I'll zoom out a bit. And you can see what's happening. I'm a mile away. Yes, I am. Alright, got that wrong. Let's have another go at that. That looks more promising. Now the flash contact has to come up into this insulated plastic piece so that the tab from the shutter will contact the wire for that flash sync lead. And they're all centered up. That appears to be correct. We have our 3 screws that hold the inner shutter case to the outer shutter case. The two countersunk head screws. One is slightly smaller diameter than the other. The smaller diameter screw goes on that post there, the one with the cutout next to it, so you can recognise it. I'll zoom you back in. There's a cutout there. That's the thinner of the two. The smaller diameter flathead or countersunk screw goes in at that point. The slightly larger diameter one goes in on the opposite side. And it's not biting, which tells me that it's probably not the right screw. Alright, well that was a surprise. That means someone has put the wrong screw in there at some stage. The other side is certainly correct. I'll have to find a replacement for that screw. Back shortly. Right, well I found the correct screw for that position in my spares. And I'll do that up. It's nice and snug. So that other one was wrong. So we had two small diameter screws there. That's very interesting. I don't regret finding that, because that smaller diameter screw, it's hard to find replacements for those. So now I've got one. Let's do up the screw for the flash contact here. That just needs to be very lightly snugged up. You don't need to screw that screw right down tight. There's no advantage in that. Checking that the diaphragm swings smoothly, that all looks good. So our front control rings can go in place. This piece connects up the aperture setting ring on the front of the camera to the tab here, which in turn controls the position of the aperture blades, diaphragm blades. I'm just running a little bit of molybdenum around there so that it will run smoothly inside this groove, which it does. And their shutter speed ring has to align correctly with the shutter speed cam below it. Checking that that aperture is coupled correctly. Certainly appears to be. Yes. Remove the retainer ring that we put on the front to hold the shutter speed cam in place while we're assembling it and testing it. This is the aperture settings repeater, or that's so that you can see the numbers at the top of the shutter. On early Retina IIIC shutters, the small C I'm talking about, the aperture numbers were only visible at the bottom of the shutter. The photographers presumably didn't like that, and that was changed at the same time that they moved to a 5-blade diaphragm from I think it was previously a 9 or a 10, I don't quite remember. But they moved to using a 5-blade diaphragm, shifted the aperture settings to the top of the shutter, and improved the spring tension on the coupling clip here, so that when you, it was a bit, with the early Retina IIICs, it's a bit prone to coming out of mesh. which basically means that if you're not watching what's happening when you shift your shutter speed and expect the aperture to move to compensate correctly, it may just stick there instead and fail to move, and you end up over or underexposed accordingly. Just checking my retainer ring tension here to make sure I don't get it up too tight. It was too tight. I'll move it around another notch, I think. Yeah. Check that action again. It should have a detent, it should be fairly positive, but it doesn't need to be difficult to move. It needs to be positive enough in its detent so that it just doesn't accidentally get moved when you're trying to do something else. Alright, see if we can get this screw started. This is the lock screw for the retaining ring. It's very small, it's very short for its diameter, so it's very hard to get it lined up vertically and started in the hole. It's also, because it's a very small screw, it's also prone to being lost, so it's not uncommon to find that shutters are missing that screw, to the extent that everybody's spares have long since been lost. All the shutters I have here in my parts collection have all had that screw poached from them already to replace the missing screw on passing cameras. That's just normal. I think everybody's lost plenty of those. I've lost a few. I've had to replace a lot more than the number that I've lost though, so I'd say it's something that you learn with experience, to watch for that screw very carefully and make sure you do not lose it. Our shutter at this stage is complete. That's ready to go, have the lens is put back in it and go back on the camera. I'm going to clean the lenses next. You won't see me do anything else with the shutter now until it's time to put the shutter back on the camera.